x, all right? I was halfway deriving the formula, right? Okay. So in this case, we take the positive value because of the graph. Okay. So you look at the graph, the gradient of the graph is always positive. Oh. Why got noise? Is that okay? Okay, so now we move on, yeah? Now, because of the graph, dy dx is greater than 0, therefore we have dy dx equals to positive value of the expression. So only this one, right? So the next one, we proceed with, so this one is done. Okay. So one more, yeah, the tangent inverse. So the previous 1, 2, 3, 4, 5, 6, 7. We talked about this 7 just now. So we continue with the tangent inverse x. So tangent inverse x is 1 over x squared. Now this one would be the last one ready. So you have let y equals to tangent inverse of x. So you know that tangent y is equal to x. So just now we have dx dy. So dx dy basically means the differentiation using the quotient rule. All right. Quotient rule. That means you have sine y divided by cos y. So you have to copy the bottom. Hey, just now we derived this one, right? Did we? Sec square. Sec. So I can use. No need to restart. Okay. So this is actually sec squared y. And sec squared y is actually, what is the identity for this one? Sec squared y is 1 minus tangent squared y. Am I right? This is the identity, right? So 1 minus tangent squared y means 1 minus x squared, because the x is equal to tangent y. So therefore you flip reciprocal of the dx dy means the dy dx is equal to 1 over 1 minus x squared. So basically this is how you get the derivative of tangent inverse. So my advice for you is, you don't have to memorize this one, right? You can actually refer to formula list MF19. I think it's all given in page, this is page 3, page 4. No, this is only for P3. So you have to look at under the further pure. Under further pure mathematics, page 5, page 6. I think it's page 6. So you can refer to the list here, all right? So the differentiation of sine inverse x, cos inverse x, sine x, cos x, tangent x, sine inverse x, cos inverse x, and tangent inverse x. Okay? So you have to remember all the formula here. But if you cannot memorize, doesn't matter. You at least need to know how to use this formula. Okay? Now, we go to the general rule. So generally, when you want to use all this formula, generally, what you need to know is the chain rule. Chain rule applies. Okay? So when I give you some general cases, how do I use the chain rule? You see, when I ask you to differentiate, right? Let's start with the first function. Let's refer to this one, sine inverse x. So suppose that I'm not asking you to differentiate sine inverse x. I ask you to differentiate sine inverse bracket. So you look at the formula. The layout of the formula is 1 over square root of 1 minus x squared. So what you need to do is you have 1 over square root of 1 minus the x, right? You change it to the bracket. Whatever inside the bracket, you copy. Then you differentiate the terms in the bracket. And this is the chain rule, the general formula. Okay. So for example, if let's say I ask to differentiate, example, yeah, I ask to differentiate sine inverse of 2x, all right? So what you do is you have 1 over square root of 1 minus 4x squared. Then you have to differentiate the 2x. So differentiating the 2x would give you a 2. Therefore, you have 2 over square root of 1 minus 4x squared. You only have an extra thing to do, which is the differentiation of the bracket. Is that clear? So if you refer to formula list 19 again, yeah, let's now look at cos inverse of x. So for cos inverse of x, you have negative 1 over square root of 1 minus x squared. Now what happened is, if I am not asking you to differentiate cos inverse x, I ask you to differentiate cos inverse of a bracket. So let's say I ask for, I change color. So I ask for the differentiation of cos inverse bracket. So you know the layout of the formula is negative 1 over square root of 1 minus bracket squared. So remember to differentiate whatever inside the bracket. Okay, so similarly, I can give you another example. Let's say I ask for the differentiation of cos inverse, let's say x over 2. So what happened here is you will get negative 1 over square root of, you have 1 minus x squared over 4. Then you have to differentiate the terms in the bracket, which is x over 2. This one is actually the chain rule, this part. Okay, this part is actually the chain rule. This part, chain rule. This one also chain rule. Okay, so of course you cannot stop here. You have to simplify further. So when you simplify further, right, this one is a bit tedious. You have negative 1 over 2. Then at the bottom, right, you have square root of 4 minus x squared divided by 4. So you simplify further, you will get negative 1 over 2 times. Then you have 1 over square root of 4 minus x squared divided by 2. So the 2 and the 2 here cancel. And therefore, the final answer is negative 1 over square root of 4 minus x squared. Okay? So the rest apply. The rest means you're going to write down yourself. If I ask you to differentiate sine bracket, so for this part here, if I ask you to differentiate sine bracket, you change the x here to bracket, then you have cos bracket, then continue with the differentiation of the bracket. The most important thing is remember to differentiate whatever inside the bracket. Okay? So similarly, cos x means sine x. So differentiating cos bracket means sine bracket differentiate bracket. That is the chain rule. And the rest all follow lah. Is that clear? Okay. So let's look at some example. Let's look at some example. Okay. So we come back to this. Let's look at the example. Example number 1. Right. Example number 1. Find the derivatives of the following with respect to with respective to x. No, I think it's just with respect to x. There's no respective in this case. There's no IVE. Just cancel the IVE. So we do number 1A. So let's look at number 1A. So example 1A. We are required to differentiate sine inverse of x over 3. So If you cannot remember, right, you can always refer to MF19. So MF19, sine inverse x means 1 over square root of 1 minus x squared. So this is therefore 1 over square root of 1 minus bracket squared. Don't forget to differentiate the terms in the bracket, which is x over 3. So this one is x over 3. So simplify further. So you have 1 over 3 multiplied by 1 over. So this will therefore give you square root of 3 minus x squared over 3. Because the bottom you are going to get a 9. So the 3 and this 3 cancelled. Hence the answer is 1 over square root of 3 minus x squared. Okay, so that is question number 1A. Number 1B. So let's look at 1B. The question asking for one B, cos inverse root x. All right, cos inverse root x. So what do you have here? 1B. So the differentiation of cos inverse root x. So this one is negative, right? Because the graph is always negative. So negative 1 over square root of 1 minus bracket squared. Then don't forget to differentiate the term in the bracket. So the term in the bracket is actually x to the power of half. So this one is root x. So therefore, you get the answer negative. You differentiate this part. You have half x power negative half followed by 1 over square root of 1 minus x squared. So therefore, the final answer is negative 1 over 2 square root. Okay, there's one extra x there. So square root of x times 1 minus x. Yes?
Sorry to interrupt. For
Yeah.
1A, isn't it should be 9 minus x squared?
9? Oh,
9.
yes, 9. It should be 9. It should be 9 here. Should be 9 here. So this one should be 1 over 9 minus x squared. All right. So for the bottom one, this one, there's no square. Sorry. Only 1 minus x. So therefore, the answer is this one. Only like that. Negative 1 over 2 times the square root of x times 1 minus x. You multiply or you don't multiply also doesn't matter. It's up to you. Right? So question number 1C. Question 1C. Now, to differentiate sine inverse x in the bracket square. Now, you got a power outside. And remember, I said power rule is powerful. So you need to use power rule first. So 1C. When I want to differentiate sine inverse x in the bracket square. So you see or not, outside the power, outside the bracket, you got a power here, and power rule is powerful. So you have to use power rule first. So to apply the power rule, you have 2 bracket to the power of 2 minus 1, then differentiate whatever inside the bracket. This is the power rule, followed by the chain rule. All right. So this part is the chain rule. This part is the chain rule. Okay. So now move on. You copy down sine inverse of x. This is to differentiate sine inverse of x. Okay. So therefore, you have the answer. You have 2 sine inverse of x divided by the differentiation of sine inverse x is actually 1 over square root of 1 minus x squared. Finish. So that's how you do 1A, 1B, and 1C. Now go to question number 2. So question number 2, I did it just now. By differentiating sine x over cos x, prove that the differentiation of hyperbolic tangent x is equal to sec square x. I do this one just now. Now question number 3. Question number 3 is the differentiation of sec x, and this will give you negative sec x hyperbolic tangent x. So sec x tangent x. So to prove this one, you have to use quotient rule. Okay, so you have to use quotient rule. So question number 3. I skipped number 2. Number 2 we discussed already just now. So for number 3, you have to differentiate sec x. So to differentiate sec x, you have the differentiation of 1 over cos x. Right? Excuse me. So this one you will have to use quotient rule. Copy cos x, differentiate 1, you get 0, minus copy 1, differentiate cos, you get sine x divided by cos squared x. This is by using the quotient rule. So this will therefore give you negative 1 over cos x, that is the first term, multiplied by sine x over cos x. So this is equal to negative sec x multiplied by tan x. So you get the answer already. So that is for number 3, right? So far, question number 1, 2, 3, any problem?
No, sir.
Okay, good. So if you have no problem, then we move on to question number 4. Number 4, you have y equals to half sine 4x. Okay. So number 4, y is equal to half sine 4x. And then 4 sine 2x plus 6x. So 4 sine 2x. So this is plus 4 sine 2x and then plus 6x. Okay. Plus 6x. Okay. So dy dx as usual. Then the constant in front you just copy half. Now you have to differentiate sine 4x. So differentiating sine 4x will give you cos bracket, differentiate the terms in the bracket. Then the next one is plus 4. Now you differentiate sine 2x. So you will get cos bracket, then differentiate the terms in the bracket. Differentiate 6x, that would give you positive 6. Okay, so now you fill in the blanks. So you have cos 4x here. So you are supposed to differentiate 4x here. Then for the second one, you have 4 cos 2x here. So you are supposed to differentiate 2x. So now answer. Answer should be, you have, so you differentiate 4x, you get 4. So 4 divided by 2, you get 2. So 2 cos 4x. Followed by differentiating 2x will give you 2. 2 times 4, you get 8. So plus 8 cos 2x plus 6. So that is how, that is how you solve problem number 4. So they ask you to show that dy dx is equal to 16 cos to the power of 4x. So it's not done yet, It's not done yet. So you are supposed to change everything to cos to the power of 4x. So continue. So you have this one now. And you may need to use the identity. So this identity is very similar to double angle formula that you have in your trigonometric identity, the double angle formula. So continue. So I have, okay, I write it here. I have 2. Now cos 4x, so let's recall. Cos 4x basically means what? So we recall cos 4x. This is actually very similar to, now because I want cos x, so therefore I change it to 2 cos squared 2x minus 1. Okay? By Osborne's rule. This one is very similar to the double angle formula. Then after that, I have to do something about this part here, cos squared 2x. So cos 2x in the bracket square. So I continue. I have 2 something square minus 1. So cos 2x, you use the double angle formula again. You have 2 cos squared x minus 1. So you get this one. And therefore, you can proceed. You have 2 times, expand this one, you have 4 cos to the power of 4 x minus 4 cos squared x plus 1. Then this whole thing minus 1. Okay? So move on, you expand, you will get 8 cos to the power of 4x minus 8 cos to the power of 2x, then plus 2 minus 1, so it's just plus 1. So that is the expression for cos 4x. Next one, expression for cos 2x. So cos 2x is equal to 2 cos squared x minus 1, right? So we are using this one here. Okay, so therefore we can proceed with our solution. Our solution continue. So you have the dy dx is equal to 2 times cos 4x. So you have 8c power 4 minus 8c squared plus 1. Yeah, I should have just defined c as cos x. And then plus 8 multiplied by cos 2x. So you have 8 times 2c squared minus 1, then plus 6. All right. So you let c denote cos x. Okay. So you expand everything. You get 16c power 4 minus 16c squared plus 2. Expand the following part. You have positive 16c squared, then minus 8, and then plus 6. So now you can see some of the terms can cancel, isn't it? Some of the terms cancel here. 2 plus 6 minus 8. Negative 16c squared plus 16c squared. So left only 16c to the power of 4. That's how you get the answer. So the objective is achieved. Okay. So I have done 1, 2, 3, 4. Okay. So now I proceed with number 5. So number 5, given that y equals to sine inverse x plus tan inverse x, x is in between -1 and 1, right? So they told you that is the condition, because otherwise tan inverse x is undefined. Yeah? Show that dy dx is equal to 0 for only one value of x. So that means you have to solve the equation dy dx equals to 0. So you must first obtain the expression for dy dx. Okay. So move on. I have, what's the expression again? I forgot. This is question number 5. Sine inverse, tan inverse. So number 5. Y is equal to sine inverse x plus tan inverse x. So you have to use the formula. Now this one, no chain rule involved. It's just the most basic one. This is the most basic one. So sine inverse of x equals to 1 over 1 plus x squared in the square root. 1 over square root of 1 plus x squared. And then plus. So what about tangent inverse x? Tangent inverse x is just 1 over 1 minus x squared. Okay. So plus 1 over 1 minus x squared. Right. So you have to set this one equal to 0. So set this equal to 0. That means you have 1 minus x squared is equal to okay, negative 1 over negative 1 minus x squared is equal to square root of 1 plus x squared, right? So you square both sides. So now you can square both sides. Okay. Then later on you have to show that you only have one answer. So you square both sides to solve the problem. So you will get the answer 1 minus 2x squared plus x to the power of 4, and this is equal to 1 plus x squared. So simplify further, you have x to the power of 4 minus 2 minus 1, so minus 3x squared. 1 and 1 cancel out, so this is equal to 0. So factorizing x squared, you have x squared minus 3, and this is equal to 0, right? So therefore, the solutions that you get here would be x is equal to 0, first answer, or x is equal to plus minus square root of 3. However, if you look at the question, they say, show that dy dx is equal to 0 for only one value of x. So for only one value of x, but now I got 1, 2, 3, 3 values. Actually, you should have 4 values, by the way, because x squared equals to 0. So x is equal to 0 is a repeated root, but we only write down one time here. So x equals to 0, or x is equal to plus minus root 3. Okay. Anyway, by right, you should have x equals to 0, or 0, or plus minus root 3. Right? So you only have one solution in this case, which is x is equal to 0. Then you need to reject plus minus square root of 3. Why? Can anyone give me the reason? Yeah, you look at the set of values of x given here, number 5. They told you x is in between negative 1 and 1. Why must x be in between negative 1 and 1? Because otherwise tangent inverse x is undefined. So therefore, you see they are very kind. They give you in the question. So you just put there, since x in between negative 1 and 1, therefore x is equal to 0. Only one solution. Finish. So that's how you complete number 5. Okay? So far, okay? I think too many things for you today, because you have a lot of formula. You have all this formula here. I don't expect you to memorize this one, all right? But if you can remember how to derive the formula, that would be good for you. Okay? Formula list MF19 must always be ready when you do the differentiation and integration. Because to be honest with you, if you look at this, it can be quite confusing. You see, you have 1 over x squared minus 1. Then over here, you have 1 over square root of 1 minus x squared. You see or not? The sequence terbalik. Once the sequence terbalik, the results are different. Then you see you have 1 over square root of 1 plus x squared, another very similar one. 1 over square root of 1 plus x squared. So you must always be careful. And tangent inverse x. Tangent inverse x is 1 over 1 minus x squared. This one versus with tangent inverse x. So for tangent inverse x is 1 over 1 plus x squared. That's why I said formula list MF19 must always be ready when you do the differentiation and also integration. Otherwise, it's quite confusing. Because sometimes I myself also cannot remember some of the sequence, all right? I also refer to the formula list, even though I can derive it. Okay? So for the next one, I think is no, we have about 8 minutes left. Let's see if we can proceed with this one. Okay, I think This one is quite long, but because the answer is given, all right? Question number 6. It is given that y is equal to cosec inverse x. Show that for x greater than 0, dy dx is equal to negative 1 over x square root of x squared plus 1. And write down an expression for dy dx in terms of x for x less than 0. So for question number 6, you do it as homework, all right? You do it as homework, and I will discuss with you maybe tomorrow is Friday, right? Tomorrow, Friday, can I meet you in the afternoon around 2:30 p.m.?
Can, sir.
2:30 p.m. Okay.
Okay.
Okay. So I will continue with. Okay, tomorrow you want me to continue with this one, or you want me to do the FP2 lecture 1, which is the matrix?
We finish this chapter better,
This
or
one first.
I think for me,
For you,
finish this first. Yeah, and then
Do we need to?
only then go
Okay,
back.
okay. This one would be very complicated, right? Because the difficult part will start tomorrow then. So